I'm running developer relations at a company called 12 Labs, and for this short technical talk, I will go over the next generation of video understanding. So when we think about video understanding, these are some of the things that you probably come to your mind. It can be very specific tasks like emotion recognition, pose estimation, to things like object tracking, semantic segmentation, right? So these are very specialized computer vision architecture built to process content from the video. And this is a quick slide that talk about the evolution of video understanding over the past century. Video was first invented back in the late 19th century, and back then, in order to understand the content, you have to manually watch through the whole thing. And then the first speech-to-text model was commercialized in 1996, and with that advancement, people were able to generate transcript from the video. But the transcript here is very difficult to read, and they also disconnected from the visual information in the video. And since the introduction of the first convolutional neural networks architecture by Jan LeCun back in 1997, up until the deep learning boom of 2012 with like AlexNet, ImageNet, MobileNet, ResNet, etc., people have been using convolutional neural networks to build specific computer vision that generate metadata, which is the tags. So let's say if there's a person, there's face, clothing, etc. in the video, they will generate those tags. And then when you try to do search, for instance, in that video, you actually work with those metadata. The issue here is that these tags often do not capture the full meaning or context of the video, and then can also create a huge discrepancy. So I could argue that we are seeing the rise of video foundation models to transform the way people are doing research for video understanding. So just like how foundation model has been disrupting images, text, audio, we are seeing the same thing for video. These video foundation models generate multimodal embeddings from the video content, which these embeddings can then be wrapped up as API for downstream tasks, and the task can then be exposed to video-centric application in a wide-ranging industry, as you can see in the slide, and then the application could then be consumed by the end users and enterprise. And in this age, I think users and enterprise definitely will demand this application to be real-time and intelligent from the get-go. So going deeper into video foundation models, what they do is they generate video embeddings from the video itself. So unlike some of the unimodal methods that focus only on the image or text or audio, if you think about video, is inherently multimodal, because there's the visual, there's conversation happening, there's sometimes text on screen as well. So we need a model that can capture all of those different modalities in the video and then generate rich representation from the video. And one of the most interesting, I would say, downstream tasks that we can get from this video embedding is video search. So think about searching for, semantically searching for a specific content inside a video frame, just by typing a query, So today, maybe find me a scene where all the audience is sitting in the theater watching a talk, and they go return the exact video clips that match with that query, and that's only become available because of advancement in embeddings and multimodal model. Recently, 12 Labs have been building a state-of-the-art video foundation models for any-to-any retrieval called Marengo 2.6, and as you've seen here on the slide, it's a very simple architecture describing the end-to-end process of the model. Taking the input, process different modalities, fuse them together, concatenate them in the same latent space, and then generate multimodal embeddings out of that. These embeddings can then power our search API, and I described a little bit earlier, but we use multimodal techniques to capture these complex relationships among the visual, conversation, spoken words, and on-screen text. That also help detect some of the more fine-grained details frequently overlooked by the unimodal methods, and it also supports natural language query for more intuitive user interaction. So besides video foundation models, personally, I'm so very excited about the rise of video language modeling. So this is basically a combination of video and LLM, So in addition to the Marengo 2.6 model that I shown in the previous slides, we also recently released a model called PKSS1 that take in video as an input and generate text as an output. So I think about like, chapters, summaries, description, right? So conditioning on the video input, you can get like textual representation of what's going on in the video frame itself. And again, we wrap our model in a suite of API. So here we have like 3 separate API: gist API, generate titles, topic, and hashtag; summary API, create summaries, chapters, and highlights; and then the generate API allows you to generate, open-ended text, conversation. You can ask questions to the video itself. Think about like a video chatbot that you can interact with. Probably don't have time for the demo, but if you're interested in our labs, you can go to our web, try our technology at playgrounds.toilabs.io. And then I personally like super excited about multimodal. So I also moderate like a Discord community that focus only on multimodal. So if you want to go and hang out with like other, researchers, developers, founders working in this space, feel free to, scan this Discord and jump into our channel. Thank you.